Welcome to APDesign Digital Tools. The next thing that we're going to do, if you haven't been following the Spaceframe, this is a continuation of Spaceframe301. You might notice that there's been a kind of a missing component to the Spaceframe. It's this bottom set of chords and web members. Now, the way that we've built it and decided to build it, we might have some trouble kind of creating that. So let's take a look at what we have. This line right here is all the connections from the grid to the centroid, the lowered centroid. So if we look at that, we have a series of lines, and we actually might want to look at the centroid, this moved centroid. I'm going to go ahead and give it a group. I'll make that the default color. So this is another centroid. So this is the moved centroid. So if we look at that, we have it's set up in a grafted list. Okay, you might look into and see that there is a kind of an address to the grafted list, that on the third part of the address there is differential. There's a 1, there's a 2, there's a 3, and that keeps climbing. Let's see how far it goes. Okay, so it's really not going to help. It's really just the 75 elements. So it's basically a flattened list. If we flatten it, we would see that there's 74 elements. Obviously, I did not want to do that before it goes into the line, so let me turn that off. So how do we get that information to basically reconstruct a series of lines that would connect this and in a way that looks like the web members? Now, essentially, this is what I'd be going for. If I go ahead and copy this information one more time over, what I'd be looking for is to build a curve that essentially connects each of these lines in this direction, and then also connects each of these lines in the opposing direction. So that's what, that bottom set of web members. Alright, so what I need to do is I need to get this information into a series of kind of column and row orientation. So to do that, you have to get a little clever. Essentially, let's go ahead and just flatten the list. So I'll use this flatten tree. We'll see that now, instead of multiple lists with just one element, now we have one big list with all the elements. And I'm going to use what's called a subtree. I'm sorry, a sublist. So a sublist, what it does is that it allows you to use a domain and essentially just grab a range, a domain range from that list. So if I just put in 3 to 6, we'll see which ones were like 3 to 6. So we should see a couple of highlighted. There they are. These guys right in here, those are that domain. So if I increase this, or decrease it to 0, we should see the rest of these guys. And if I increase this, maybe increase this even more, eventually we'll have that kind of entire row. So right there. One back. So that's that entire row. So essentially what I'd want to do is then that I would create an interpolate curve for that. And so it would be basically a connecting web member that would connect all those. And I would do that again for the next row, the next row, the next row, the next row. Well, that sounds a little painful. Essentially, it's kind of what I would call the brute force method. Basically, I would switch this over, just increase these a bit. So this is suddenly going to become 15. And then this would increase by 15, so essentially 29. And so this sublist now is that row. And I keep on doing that endlessly. Let's just imagine, I mean, the kind of, not only is it kind of brute force because I'm going to have to kind of mess with sliders and keep going, but let's just imagine that down the road I decide, well, you know, not 15, but 25 would be even better. And maybe not this, but that. Suddenly I've got to then create a whole new list, you know, more of these subsets, Not a good idea. Brute force is fine if you're just getting started, but eventually you want to clean things up. And you want to do things with a little bit more intelligence. So we're going to add a little bit more intelligence to the system. Alright, so you might notice that as I went through this list, that really all I'm doing is I'm going 15 up. You know, 0 to 14 is 15. You might notice that that is, you know, the V count. And if I was to play this thing out, you know, brute force wise, I would have to replicate that 6 times. So I've got the numbers. I know exactly what I'm doing as far as you know, how far I'm having to step. So what I'm going to do is I'm going to use what's called a series. And series are great. Series allow us to get a series of numbers. How many is up to, you know, it defaults as 10. If we plug this in, we'll see that you have a start value, which is 0 as default. You have a step size, which is 1 at default. And then you have a count, which is 10 as default. So this is what you'd get. It's going to start at 0. It's going to count by ones. And it's going to count by ones until it gets to a 10th number. So now we're 0 to 9. 10th number is 9 when you start at 0. Fine, great. Well, what I'd really like to do is I'd like to create a domain that uses that idea. So let's just imagine we just plug this in right now to the A. Let's see what we get. So what we get is our first number out of that series, remember, was 0. And I'll go ahead and let's look at it side by side. So the first number out of the series is 0. So now we have a domain 0 to 14. Remember that 14 is our static B. So 0 to 14, then we'd get 1 to 14, then 2 to 14, and 3 to 14, and so on and so forth. Alright, now, that seems somewhat handy, but not really what we're looking for. So let's just imagine how many of these, if we start at 0, and we're looking at, again, kind of what we did brute force-wise, 0 to 14, and then 15 to 29. Essentially, we need a step size that is 15, right? Because 0 to 14, 15 to 29. So a step size of 15, or, better yet, a step size that follows the V count. The V count, as that changes, remember if we set this at 20, then suddenly we might want a step size that is 20. So we'll click that in there. The next thing we need to know is how many of these are we going to do. Well, we know from brute force that if I keep on replicating this idea, I'm going to need to do it 6 times. Or, in other words, I'm going to need to replicate it by my U count. Great. Now let's take a look at what we would get with that. So 0 to 15, 15 to 30, 30 to 45, so on and so forth. So if we look at this, the 0 is what we use for the first one. The 15 is what we use for the second one. 30 would be what we'd use for the third one. This sounds like good information. Perfect. Let's use that. That'll be all of our A's. Okay. Now let's look at what our B's would be. Our B's need to be 14, 29. So essentially it's still counting by 15s, but instead of getting to instead of going to 15, we need it to start at 14. Well, that might be pretty easy to do. Let's just think about what we would do. If we need to start at 14, let's go ahead and plug this S also into the 15. But now we're going to put a little expression in. We're going to say, yeah, I want that start value, but I want a -1. So I put in X, which is any variable in your expression that is the input. That's a constant in Grasshopper. X will always be used. X -1. Now let's take a look at what we get from that panel. So 1429. That looks pretty good. 1429. So let's use that as our B. Alright, now let's plug this in. So now our domains are going 0 to 14, 15 to 29, 30 to 44, 45 to 59, 60 to 74. Alright, we have a little bit of an issue I see here, 75 to 89. If we look at our flattened list, oh, it does go to 89. Perfect. Alright, I think we're good. I must have shifted a slider earlier. It used to go to 74. Alright, we're good to go. So now, our sublist should be giving us exactly what we want. So essentially what it's doing is it's giving us 0 to 14 in one list, 15 to 29 in a second, third, fourth, and so on and so forth. Let's look and see if it did that. So we got the first list that goes up to 14. Then we start another list. Great. Let's go ahead and add an interpolate curve to it. Connect the dots. Interpolate curve may actually not be the right answer. This is a web member that probably is straight. So we might actually want to use the polyline. So now we get a series of lines, web members at the base. And now we simply flip the matrix. Now this is a very key and great component that came about 3 years ago in Grasshopper, maybe even 4 years ago. What it does is it flips the matrix. So if you have rows that are 15, made up of 15 elements, and your list goes up to, say, in this case it goes from 0 to 5, flipping the matrix will change the number of lists. Instead of being up to 5, will go up to the 14, and the number of elements in the list will go from 14 to 5. So essentially you're just inverting the column and row structure. The columns go to the rows go to the columns. So let's take a look at that. So this is how it's set up now. 6 lists, each with 15 elements. Now we look at this, we have 15 lists, 0 to 14, and we have 6 elements in each. So you see how that inverted. And so we'll just do that. So what this is doing now is it should be drawing a line from that point to that point to this, to this, to this, to this. So we'll click, create a new polyline, connect it. Great. Alright. So now you have the completed space frame. These are the ones that we'd want to bake. We'd also want to bake these, so I'm just going to start to pile these all together. If you want to be a little bit more, kind of more tectonic, you may want to start piping. Now, realizing that piping is going to add a lot more processing time to your computer, but you actually might want to actually bake this and get this to Rhino. So that may be in order. Okay, it looks like I'm missing one more element. These top ones. It's always good to grab these and those are curvilicious too, aren't they? Alright, so in order to see exactly which ones I should be doing, I'm going to turn it off, turn it back on. Alright, so it's this one. So I'm just going to add a curve element, plug it in here, and then I'm going to slide that all the way over. So essentially this becomes all the elements that I would want to bake. You can add even more I'm going to add a number to this. You could add even more tectonics. You could actually put more of a spherical ball at the joints. That would be even better. So you start to kind of create a series of spheres at your points of intersection. So these two. Again, all these things take up quite a bit more processing time. Let's take a look. This is right back here. There's that, and maybe this one too. So what I'm doing here is I'm starting to collect then all of the things that I might want to bake. And I'll group those. And I might designate a different color for things that are of baking flavor. Alright, cool.